So quiz 19, we're dealing with our double angle formulas and our half angle formulas. Remember, our sine double angle, we only have one, but with our cosine double angle, we have three. And it helps to know all three, but you should definitely know at least one. And so why don't we use cosine 2x is equal to cosine squared x minus sine squared x. And so it might help to use the double angle cosine formula that just involves your sine squared x because they only give that to you. However, I'm choosing this one so that if this is the one that you just know, how can you find your cosine x when you're only given sine x? And how do you do that? Well, you're going back to your good old SOHCAHTOA. This is our x. Sine of x is opposite over our hypotenuse. So 5 is the opposite side. 13 is our hypotenuse. We're in quadrant 1, so everything is positive. And if you haven't noticed that 5, 13 creates a Pythagorean triple, 5, 12, 13, then you can also just do your good old Pythagorean theorem off to the side. We'll say a is our 12, so a squared plus 5 squared equals 13 squared. 13 squared is 169, 5 squared is 25, 169 minus 25 is 144. Square root of 144 gives you that 12. And then from there, you can very easily identify that your cosine of x is your adjacent over your hypotenuse, which is 12 over 13. Again, everything is positive. Yes.
Could I also use the Pythagorean identity as well? With cosine squared plus sine squared equals to 1? Because that's what I did. Because I knew that since sine of x was 5 over 13.
Yeah. To find your cosine of x, yeah,
Yeah.
you can definitely do that. Yep. That's another way to do it. Good. And now you just want to sub in. So your cosine of 2x is equal to 12 over 13 squared minus 5 over 13 squared. You know that the denominators are both going to be 169. 12 squared is 144. 5 squared is 25. 144 minus 25 is 119. So we get cosine of 2x is equal to 119 over 169. That's it. I'll also put in the other two double angle cosine formulas. Well, maybe I'll put in the sine one too, because you really should know these, especially for your exam next week. We use the first one. The second one is the quickest, because then we don't have to solve for cosine. All right, question 2, we're dealing with our half angle formulas. So our half angle for sine of alpha over 2, we're looking at plus or minus the square root of 1 minus cosine alpha all over 2. They give us cosine alpha, which is great. But we determine whether it's positive or negative based off of alpha over 2. and they only give us alpha. So we need to divide this alpha by 2 and divide every side by 2 as well, so that we can see where alpha over 2 lies. It lies between pi over 2 and 3 pi over 4, which is in our second quadrant. And in our second quadrant, all sign-related functions are positive, meaning we are going to neglect that negative and hone in on the positive. And now we just sub in. So 1 minus negative 3/5 all over 2. 2 negatives turn to a positive. 1 is the same as 5 over 5. So 5 plus 3 gives you 8. And then 2 as a fraction is 2 over 1. So notice how we're going to do a keep change flip to get the square root of 8 over 10, which is the same as the square root of 4 over 5, which is the same as 2 over square root of 5. Rationalize the denominator, and we get 2 square root of 5 all over 5. And we're done. Questions at all? Now, the last two questions, we've already done them together, but we'll do it again. It'll be nice review. I did notice that some people, even though we did these questions together, they still decided to solve these questions on their own and did not solve them correctly. So anytime we do questions together, pay attention, copy down what we're doing so that you can get full credit for the question itself. Right, so we have solve the trigonometric equation square root of 2 cosine of alpha minus 1 is equal to 0 for all values of theta on this interval. So let's write it out again. We have square root of 2 cosine alpha minus 1 is equal to 0. Let's go ahead and get that cosine theta by itself, utilizing your inverse operations. And divide both sides by square root of 2. And then you're going to want to rationalize that denominator by multiplying by square root of 2 over square root of 2. So you get cosine of theta is square root of 2 all over 2. And they tell us that we're looking for all values of theta between 0 and 2 pi, between 0 and 360 degrees. What is our reference angle? Cosine of what will give us square root of 2 over 2?
Pi over 4.
Yeah. Also known as our 45 degrees. And it's positive. We didn't take the square root of anything, so we're not looking at plus or minus. So if it's positive and we're dealing with cosine, what quadrants are we going to be in? Yeah, exactly. 1 and 4. We know in that first quadrant we have pi over 4. In that fourth quadrant, what do we have? Not 3 pi over 4. 7 pi over 4. And those are our only two solutions. So theta equals pi over 4 and 7 pi over 4. I think I wrote a 2 here. Questions at all? Right, we have one more question. Question 4. We have solved the trigonometric equation cosecant squared theta minus 2 is equal to 0. And then our bounds here are going to be once again between 0 and 2 pi. So 0 and 360. Write out our equation. Utilize your inverse operations by adding 2 to both sides. So we get cosecant squared, which is the same as 1 over sine squared theta, is equal to 2. Let's cross multiply. So we have 2 sine squared theta is equal to 1. And then let's bring the 2 back over. So we're just looking at sine squared theta is equal to 1/2. But now we want to take the square root. Whenever you take the square root, we're dealing with plus or minus. Square root of 1 is just 1. So we have plus or minus 1 over square root of 2. Rationalize the denominator. And you're looking at plus or minus square root of 2 over 2. Okay. So what is our reference angle going to be? Because we're dealing with plus or minus, do we have any restrictions for quadrants?
No.
Correct. Which means how many solutions are we going to have? Yeah, good. So our first one is going to be pi over 4. What about in our second quadrant? Yeah. What about in our third quadrant? Yeah. And last quadrant? So therefore, our theta is equal to pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. That's it. This completes our quiz 19. Questions at all? No. All right, so let me stop recording.